welcome to our video on
Hey guys!
Welcome to our video on graphic polynomials. There's nothing more exciting.
You may be
You're
thinking.
so right. There's
So
nothing
today,
more exciting.
we're going to take you
You're
through
so
all
right.
the steps.
So today,
we're
we're
going to
taking
graph
all the
and drawing
steps
a rough
of
sketch.
finding the key parts
So
of
let's
the
get
graph
started
and drawing a rough sketch.
Okay,
So let's get
this is our
started.
first function.
So you
Okay.
may be thinking.
This is our x squared
function.
before an x to the
So you
4.
may be thinking.
That's simply
x
an
squared
outrage.
before an x to the 4.
You're right.
That's simply
This
an
isn't
outrage.
in standard form.
You're right.
Now, it's standard
This
form
isn't in
means
standard form.
is that
Now, it's standard
the
form
variable
means
with the highest degree goes
is
first,
that
and then
the
consecutively
variable
after
with the
will be
highest
variable
degree
with
goes
second highest
first,
degree,
and
and
so
consecutively
on.
after
So
will
we
be
want
the
to put this
variable with
function in
second
standard
highest
form
degree,
to
and so
begin.
on.
So
we
what
want
that
to
would
put
look
this
like
function
is
in
standard
standard
form to begin. So what that would look
We would
like
have
is
f of x
equals x to the 4
We would have
minus
f of x equals
13
x
x
to the
squared
minus
13
36
x squared. So this isn't standard
plus
form. We're so excited about it. So this isn't standard
Next
form.
thing we want to do is
So
find our
excited
leading
about it.
coefficient. And that will
Next
tell
thing
us
we want
whether
to do
our
is
graph
find
is
our
going
leading
upwards or
coefficient,
downwards.
and that will tell us whether
So how
our
we
graph
can
is
find
going
that?
upwards or
Cool
downwards.
words.
How we can find that is if we again look at our variable with the highest degree, which is x to the 4th, and then see what the coefficient is before that. So our leading coefficient is going to be 1. That's a positive number. So we have a positive LC, or leading coefficient. And this means that our graph is going to open upwards. So now we know that. Next, we want to look at our end behavior, and how we can find that is again by looking at what degree our function is. So we already know from the previous part is that it is x to the 4th is our variable with the highest degree. So we have x to the 4th. And then if we look at 4 here, we know that that is an even number. So our graph is, or our function is an even degree. So what this means is that it tells us our end behavior. So as x approaches infinity, f of x, or y, will also approach infinity. And then as x approaches negative infinity, f of x will still approach infinity. And then the last thing we want to look at is how many turning points we're going to have. So the reason, or how we can find this, is with the formula of n minus 1. So n is going to be, again, our degree. So 4 minus 1 equals 3. So we know that at most we will have 3 turning points.
We're going to find factors. So the definition of an x-intercept is when y equals 0. So 0 equals x to the 4th minus 13x squared plus 36. And then this factor is x minus 3 times x plus 3 times x minus 2 times x plus 2. And then you set each of these equal to 0. So x equals negative 3, 3, negative 2, and 2. And I will graph it.
Hey guys, okay. So now we're going to graph it. And as Ali found earlier, we know that the function opens upwards. So we know that we have this. And then, so as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches infinity. And then Ali told us that because the formula to find the turning points is n minus 1, and 4 minus 1 is 3, we know there has to be 3 turning points. So clearly this graph has 1, 2, 3 turning points. So yay, and we're going to go on to another example.
Okay, so now we're going to look at our second example. So this function is already in standard form, and what we're going to do again is we're going to go through the same process. We are going to find our leading coefficient, and we're looking at x to the 3rd right here. Leading coefficient again is 1, positive LC. Then we are finding our end behavior, so we're going to find what degree our graph is, x to the 3rd. So our degree is 3. This is odd degree, and this tells us that differently from our first example, as x approaches infinity, f of x will approach infinity, but as x approaches negative infinity, f of x this time will also approach negative infinity because it's off degree. And then lastly, we're going to find a number of turning points using the same formula from before. So n minus 1. This time we're using 3 instead of 4 because that's the degree of our graph. So 3 minus 1 equals 2, and we know, just as we said before, that at most we will have 2 turning points on our graph.
Okay, so now we're going to factor this again to get the x-intercepts. So you set the equation equal to 0 by definition of x-intercept, and then you could try factoring by grouping, but that doesn't work. So then you have to use synthetic division, which if you need help with that, you can go to the factoring video. So the factors of this are x equals negative 2, negative 1 with a multiplicity of 2, which Maya will talk about.
So, as Alex stated earlier, as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. So we know that our graph is going to go in this general direction. And then Veronica stated that we have x-intercepts in negative 2 and negative 1. And you may be thinking, what does a multiplicity of 2 mean? So what that means is that when the graph is going to hit negative 1, it's simply just going to touch the point and then go away. So when there's a multiplicity of an odd degree, the graph goes straight through. But when if it's of an even degree, it just touches it. And Alex stated that we were supposed to have 2 turning points, which we do. One here and one here. And now keep in mind that these graphs are just rough sketches, and if you want to make sure that your graph was correct and it looked great and everything, you can check out the graphing video. But this looks pretty good, and we're just going to give it a big old smiley face. So we love math. Thank you for watching.